G'day. How's everyone doing? Woo? Can I get a woo? I need a little energy. Come on. Okay, now I'll talk about something serious. Okay, thank you. Confidentiality for your data and code is critical in computing. In the ephemeral world of container orchestration, we need to pay attention to protecting data. It's hard enough to ensure data confidentiality at rest and in flight. And up until this point, it's almost impossible to make sure that your data has been protected during processing. In the wider cloud ecosystem, application security considerations include consequences of unauthorized data access, data leaks, establishing trust in infrastructure, and the need for regulatory compliance. Given this, we need hardware-level data protection where sensitive data can be processed confidentially and verifiably with guarantees. Security requires us to focus on every layer of abstraction, on hardening the application, the VM's operating system, the hypervisor, and host kernel. Great projects such as gvisor and Firecracker handle security for sensitive workloads at those layers. But what is often overlooked is the hardware beneath. When you opt into confidential computing for a specific application, you can access the hardware directly, taking advantage of hardware encryption in a trusted execution environment. We're already protecting data at rest and in transit. We can now offer hardware-level confidentiality and integrity while data processing. Microsoft is happy to announce an advancement towards confidential computing in Kubernetes. We are enabling containers running on Kubernetes to create and use trusted execution environments by means of the Open Enclave SDK, which allows you to verifiably guarantee that your data and code are isolated by the hardware itself. With encryption down to the chip, you now have improved control for ensuring sensitive data remains confidential. Scenarios ranging from line of business workloads, such as payment processing, and novel workloads, such as multi-party machine learning for medical research. Organizations who have hesitated to move their mission-critical workloads can now run them with confidence. And this enables new use cases that may have been operationally prohibitive in the past, such as financial services pooling their data together and using machine learning for fraud detection. Securing data is a hard problem. Thankfully, we're working to solve this across the industry. The Confidential Computing Consortium is a community project under the Linux Foundation, and it has a charter of accelerating the adoption of confidential computing. They launched with projects such as the Intel Software Guard Extensions SDK, the SGX SDK, and the Open Enclave SDK. Hey, but we're all here for KubeCon, so it wouldn't be fair if I didn't show some YAML. I think I'm the first one to show some YAML today. But here's how easy, yeah, thank you. I'm happy to oblige. Here's how easy it is to use confidential computing in Kubernetes with the Open Enclave SGX device plugin. This device plugin determines the allocatable resources per node. And as we can see here, we have a node that has 82 megabytes of encrypted memory. We can then define in our pod spec how much encrypted memory can be used for our application. Kubernetes will then schedule the app to a node with the capability and the availability. From there, your app can create and use a trusted execution environment. So we can see that this app has requested a limit of 64 megabytes of encrypted memory. That's all there is to it. So if you're excited to learn more about confidential computing, you can try it out for yourself on Azure today and come chat with us at the booth to learn more about confidential computing and other open source projects. Cheers.